Alright, let's discuss equivalent fractions. A little bit of a review here. So equivalent fractions they're equal to each other, but they look different. So to change the way a fraction looks without changing its value, we multiply it by a form of the number 1, and 1 takes on an infinite number of forms. For example, let's consider the fraction x over x minus 2. Well, x over x minus 2 equals x over x minus 2 times 3 over 3, for example. The reason is because this 3 over 3 is just 1. So when you multiply something by 1, you get the same thing. However, if you actually do the multiplication, it looks different. This fraction looks different than its original form. It looks like 3x over 3 times the quantity x minus 2. So this fraction is equivalent to this fraction, but they look different. In fact, if you reduce this fraction, meaning cancel the 3's, you end up right back where you started. So lots of people, the way they go wrong is they write an equivalent fraction such as this one, but then they reduce it, thus going back to where they started, working in circles. So be careful with that. We're simply investigating how to write fractions so that they look different. And this is useful for lots of reasons. When you solve equations with fractions, it can be useful. When you add or subtract fractions, it can be useful. So keep that in mind. Let's look at one more alternate form for x over x minus 2. X over x minus 2 could be multiplied by a different form of 1, any form of 1 you like. So even something like x plus 1 over x plus 1. Right? This equals 1. And when you multiply those, you get x times x plus 1 on top. And on bottom, you have x minus 2 times x plus 1. So this fraction is equivalent to x over x minus 2. It's also equivalent to this because they're all equivalent to x over x minus 2. So there are some alternate forms, alternate ways to express this fraction x over x minus 2.